Hey, look at this. Traveling along, driving up to New York City. Look what I saw as I was crossing the river. Oh my gosh, danger. Unit 8 statistics. Who would have thought? Alrighty, so yes, this is Unit 8. This is a short unit, and um, and some of it will be repetitive with what you do, certainly in AP Stat, and then even like previous like middle school math classes, I once again want to highlight the pieces that are going to be used in IB. So first, just organizing and summarizing the data, right? This is old stuff that I'm going to go through pretty quickly. I think you know mean, median, and mode. I hope you do, right? Mean is the sum of all this data. The sum of all the x of i's divided by how many you have is the mean. These are all measures of central tendency. The median is literally after the data has been organized. From least to greatest. What is the value in literally the middle position? So again, here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. After I organize them from least to greatest, I would then go and find the middle position. But if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if the middle position actually does not have data in it, in other words, if you have any even set, then the median is the average of the values on either side after you've organized it, right? After you've organized it from least to greatest. And the mode is just which value occurs the most. If anybody is tied, you have two values that occur, right? 4 and 4 are in your data, and so are 6 and 6. Well, then you're bimodal. Mode not used nearly as much as mean and median, all describing the middle. Range, variance, and standard deviation are measures of dispersion, spread. Range is simply the high minus the low. Variance is after you have squared each data's distance from the mean and added them all up together. That's your variance. Standard deviation is the square root of the variance. Okay. Quartiles, quartile 1, you might say, well, where's quartile 2? Don't leave out quartile 2. Quartile 2 is the median. So quartile 1 separates says in quartile 1, you have the bottom 25% of the data. Quartile 2 is 50% of the data, right? On either side of the median. That's quartile 2. And quartile 3 is the top 25% of your data. I highlighted interquartile range. Interquartile range right? I expect that you've seen quartiles before, but I don't know if you know what interquartile range is. So instead of the range, which might include outliers. So basically your interquartile range tells you the distance between most of your data, right? right? It's like the range of your middle set, your middle 50%, I should say, right? If you quartile 1 separates right below quartile 1 is your bottom 25, above quartile 3 is your top 25. So in between quartile 3 and quartile 2 is the range of 50% of your data. Good information to have. Box and whisker plot, I expect that you have made those before. Maybe you have seen or have not seen the difference between a box plot and a modified box plot. I will be sure in the directions to highlight which one I want, or to say in the directions which one I want. If I ask you just to make a box and whiskers plot, what I'm asking you to do is make a horizontal scale, put your minimum here, put your maximum here, and then tell me where Q1, Q2, and Q3 are. So for this data, my minimum was 21.9, Q1 was 25.8, 28, I should have made more space here because Q3 is a little higher up. I'm just kind of approximating, but I want to give a decent approximation. Q3 was at 33.6. And my max was at 78.1. I should put my max higher up as well. So hopefully, I do expect that you could get these values on your calculator. If you were just doing them by hand, that is fine too. But you can just use the one variable stats piece of your calculator, right? And it gives you Q1, the median, the mean, Q3. Hopefully you can see the min and max. Also, if you don't know, Google how to, if once you enter all this data into, for instance, L1, you can operate on the list and order it, right, from least to greatest. You are perfectly able, willing, whatever. You're allowed to use your calculator and its capabilities to draw this. So box and whiskers, make a whisker at the min, the end of one whisker, and then make a box in the middle. And a box in the middle is going to cover your interquartile range, and put a line at your median. And then connect your whiskers out to your max and your min. So again, 25% of your data is here. 50% of your data is here, and 25% of your data is there. Box plot. Woot woot. This is a cute little applet for you to play around with if you like. So now this I do want to, I'm not sure how much of this you have done. I feel pretty confident that someone somewhere along in your mathematical life made you do a box and whiskers. Not sure about outliers. In statistics, outliers are really what you study, right? Why is there an outlier? Is an error in data collection, an error with my machinery that is calculating something, or is there a reason for an outlier? So we don't have any context. We're just giving numbers. I know I say this is weeds in my house, but outliers are often very important in your research. And the formula for an outlier, right, as you see in your handout, piece of data is an outlier if it's outside the range. So Q1 minus, this is a definition, 1.5 times the interquartile range. Right, so that's and it's not, I don't know. Sometimes I hesitate with these formulas because you could look up the definition of an outlier or a formula for an outlier. This is what we're going to use, what IB is going to use as well. So this is an outlier if I take my Q1 and subtract 1.5 times my interquartile range. That's on the left end. And then on the right end, if I have any outliers on the right end, it's to take your Q3 and add 1.5 times your interquartile range. So what is the boundary for my outliers of this data, right? I had Q1 was 25.8. I'm sorry, 25.8. I wrote 25, but I said 21. Minus 1.5 times my interquartile range, which was Q3 minus Q1. Trying to read my writing here. 7.8, I think that is. And then I did the same thing with Q3, 33.6 plus 1.5 times 7.8. And I got the range of, or the interval, 14.1 on one end and 45.3 on the other end. Do you have any data that lies outside this range? So check 14. Nope. How about 45? No. Oh, hello. Hello, outlier. So I have one outlier in this data, and there she blows. So to make a modified box plot, you start the same, make me a horizontal scale. Oh boy, that was terrible. 21.9. 78.1 used to be my max. But now what I'm going to do is I'm going to put 21 point, I'm going to have my Q1 still, that's not going to change. 25.8, 28, and oh, well, that's terrible. Make that further to make it obvious. I know that was the max. But now I'm going to use these numbers. I'm going to put 14.1 here. I don't have anything below that, so I'm still going to use my regular whisker there. I'm going to have my line at Q1, Q2, and Q3. But I'm only going to go a distance out here to 36.3. Where did that come from? Then I'm going to do this. This is my outlier. Okay. Where did the 36.3 come from? Look at my list. If I name this 78.1 an outlier, 36.3 And if you ordered this in a list, it's more obvious, right? This is kind of, sort of my max because it is the highest data point that has not been identified as an outlier. Okay, that is a modified box plot. Stem and leaf, again, pretty sure you've made a stem and leaf before, right? So for a stem and leaf, there's your stem. There's many different ways to do this. Right? If I just do it with the first digits there, the tens place, how many, right? I have a 2 and then a 1, 9. Now I should make a key to say that on the left side, those are in the tens places. Right? Or even just do this, 219 is equal to 21.9. That's also fine for, just tell me like what an entry in the first row means. Right? And then I'll be able to figure it out. I have a lot of things with a 2. Right? And of course I could make it this different. I could make a stem and leaf plot where I've got the tens and the ones here and just the decimals for the leaf part. Right? If somebody doesn't give you directions, make the stem and leaf plot that you want to. Just include the information about a key, so that someone can read your stem and leaf plot. All right, I'm not going to finish that. All right, now we're starting to get into a little bit more same ideas. Look, mean, median, mode, quartiles. I do introduce deciles and percentiles. I'll talk about that in a minute. But this time, I want to talk about adding. This is my original table. I added the cumulative frequency because this time they're talking about 600 students, and they grouped them. They grouped this instead of recording, everybody, how many people had 0 TVs and gave it 5 dashes. They just listed the word 5. So the cumulative frequency here is 5, right? Here I have one person that has a 123. So how many people have I been talking about then? I have 123 plus 5. Right? So 5 people had no TVs, but I counted 5. Look how many people had one TV, 123. So instead of making 123 dashes like this, I just said I have 123, but how many people did I count? Well, I counted 123, but I already counted 5. So that's what this cumulative row is. I'm just taking 128 and adding 2, right? So I added those, and then I'm taking the cumulative frequency, adding. Oops, sorry, skipped to 3. Adding. And hopefully it shouldn't surprise you that my total is 600. And if you're looking at your note sheet, you see where it says that 600 students were surveyed. So this better add to the total number of people you surveyed. That's the idea of the cumulative frequency. So we touched on this a little bit in probability, just in a different context. So if you put this in L1 and this in L2 and you run your one variable statistics on both lists, L1 and L2, the number of TVs and the frequency with which that occurs, you'll get the mean. The calculator will do the mean for you. I don't know why I wrote 3 places down. 3 places past. 2.4, 2.3 is good enough. The median was just 2. And the mode, the calculator didn't give me the mode, but can you tell what the mode is? Right? So Q1 isn't new, right? This separates the bottom 25% of the data, and my calculator told me that was 2. Q3, and I just wrote out third quartile because I wanted you to see the difference in this word and these. My calculator gave me these amounts. I didn't need any formula. But my deciles and my percentiles do have a formula. And I've written it in your notes. For any blank cile, you take the percent that you want, divide it over 100, hopefully that's obvious, and you multiply it times n plus 1. Who knows where these formulas come from? I'm sure I could Google it and find out. So the second decile, 600 was my total, n is my total. So 600 plus 1 is 601. What am I going to put in the numerator? Second decile. Decile means cutting everything up into tens. So the second one would be 20. Seventh decile, 70. How about percentile? Percentile is cutting everything up into ones. So the 44th percentile would be 44 slices, and this would be 98. So when I did these calculations, I wanted to make it relative to my data too, right? So this one was 120.2. So 120.2, where would that be? 120.2, look at your frequency. 1 TV, right? Right here. How about the 7th decile? When I did this calculation, I got 420.7. Where would that be? Right, 470. Oh, sorry, I should be looking at my cumulative frequency, silly. 3 TVs. Right, so, right, because this is actually how many people there were as I'm adding up. My 44th percentile, the decimal I got, I didn't get a decimal. I got 264. What does that go with? Also 2 TVs, right? But look at this one. This one I got 588.9-ish, almost 589. Uh-oh. What is that? Should I say 4 or should I say 5? Because this is 588. It's a little bit more than that. Oh, not sure what to do. Take the average. No, no one has 4.5 TVs, actually. Whoops, I wanted to put that here. Okay, it's like the average American family having 2.5 children. Nobody actually has 2.5 kids. That'd be pretty weird. All right, that's swell. Okay, notice the note change at the top. Class data. Firstly, look at that data. Oh my gosh, that is an awful lot of data. So to organize a large set of data, we want to group them. So we're going to group them and get some numbers, yes, but also a picture of what's going on. So the first thing you have to do is figure out the range of the data and divide it by how many classes you want. I'll tell you how many classes I want, okay? This is a very common error. Please pay attention to that. So I scanned, remember the range is the high minus the low. So I scanned my data for the largest value. I don't care how many times I see it, but that's the largest value and the smallest value. So 97 minus 22 divided by 10. Now you don't see 10 here on my handout, but you do see it in the notes. I said I wanted 10 classes. Given that I want 10 classes, I divided the range by 10 and I did not get an even number. I do not follow any rounding rules. I don't care if that was 7.01. Always round up. Your class width is 8. So I'm going to create 10 classes and I'm going to dump a bunch of data into each class. And I'm going to capture all my data. To do that, I'm going to say, well, what's the lowest to go in each class? Called the LCL. And what's the highest that is going to go into each class? And I'm going to call that the UCL for each of my 10 classes. This is actually not how I write it out. I just did this so it was about right, at the bottom of my screen following number 10. But here are my 10 classes. So I just want you to look for now at class 1 to class 2. My class width is 8. If you subtract 22 and 29, you don't get 8. And I don't actually want you to think subtract. I want you to think with class width. You start with your minimum data, and you add 8. And you add 8 to your minimum to get the next LCL. So take the minimum 22, add 8, and get 30. Then take the this class's minimum and add 8. And that gets you all of your LCLs. Start with your LCLs. Do these first. And then backfill the UCLs. So here, like I said, this is not actually how I write this out. I'll show you how I write it out, like that. So I started with my minimum. Oh, that doesn't look too good. I started with the minimum and I added 8 going down, right? Add 8. 22 plus 8, 30 plus 8, 38 plus 8, and so on and so forth. Then I went and backfilled the upper class limits, right? If 22, I filled in 22 here, I added 8 and I got 30, well then 29, right? So there's only a distance of 1 between here, right? If I was 38, then the upper class limit of the previous class was 37, and so on and so forth. And then I just calculated my frequency and what should the sum of my frequency be. Right? Look at how many pieces of data I had. Right? It said we surveyed 60, so this total should be 60. Okay, so that's how I create this frequency chart. From a frequency chart, I have to make the frequency chart first. Then I find out something called my class boundaries. Then I make a histogram. Histograms show up on IB exams, right? So yes, mean, median, mode, blah, 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 but histograms, right? Interpreting, drawing and making histograms, labeling them appropriately, and then interpreting them shows up. I don't know how much it is in AP Stat, but it does show up on IB exams. So a histogram is not a bar graph, or at least it's only a type of bar graph. And a histogram has no spaces between the bars. A regular bar graph might look like this. Right? Spaces between each bar. Now, if you look at the frequency table we made, the frequency table went from 22 to 29 and then jumped from 29 to 30. That's a space. That's why you can't go from a frequency chart right to a histogram. You have to find your class boundaries first. So notice that in my frequency chart, I had 22 to 29 and then 30 to 37. The distance between the upper class limit of one class and the lower class limit of another class, that distance was 1. Cut that distance in half. Add that value plus or minus to each LCL and each UCL. And I hope you can see where you add and subtract, right? My actual first lower class limit was 22. I took my minus 0.5 and I subtracted 0.5 from each. Minus 0.5, where did I get the 0.5 from again? Took the distance between my original LCL and the next UCL. I took that distance, which was 1, always cut it in half. Now do plus or minus. Do minus to the LCLs and plus to the UCLs. That closes your gaps. Some histograms you will see not really take 0.5 off of this one or add 0.5 to this one. They will leave those because after all, you're not closing a gap on the left end and the right end. I like to keep it consistent. I won't take off points and neither will I be if you leave this at 22 and this at 101. Technically, it shouldn't be all of the, right? They should all have the same right? Width. So some vocabulary. We already talked about class width. Class width is UCL minus LCL, not the class boundaries. The literal upper class limit minus the lower class limit. No. Gosh darn it. That's the class interval. That's the class interval. The class width, right? To find the class width, it was your range divided by the number of classes you want. Okay, so interval, and you saw I messed it up, right? Interval, interval. Come on. Now you can't see it anymore. Interval versus width. What is 29.5 minus 21.5? Hey, when you do your class boundaries, when you create your class boundaries, if you subtract that, you will get your class width, right? Not your interval. All right, so I did step 1, frequency chart. I figured out my class boundaries, and I'm going to use my class boundaries to make a histogram. Bam, there it is. Here are the things that you're going to lose points for if you don't have it. Tell me what these numbers are. However, they really represent the number of sit-ups is what I'm representing here, but the numbers along here are not real values. These are your class boundaries so that you have no space between your bars. However, every piece of data can fit into these bars, right? You can kind of think about pouring, right? I'm going to pour data into here and into here and into here, right? But because of my class boundaries, which were created after I made my classes, no piece of data will fall on a boundary. I will never have that. All my data will fit in one of those bars. And then here, you should have the word frequency. They won't take off if you don't have it, but you do need to label your scale. Ooh, this is terrible. You can't see my 10, 11, and 12. Okay, so axes labeled. You have to have the numbers and the title, and the numbers have to be the class boundary, not the class values. Your 22s, they have to be your class boundaries. You should have the word frequency here, but you won't be penalized if the word frequency isn't there, but you will be penalized if your scale here is not apparent. And then, of course, you need to make your bars appropriately, right? There were 4 pieces of data that fit into the first class. And of course, as you can see, we had constructed this so that we have 10 classes. Now look at the organization of this large data set. Can you see where the mode might be? Can you estimate where you might think the mean is just looking at the data? Can you estimate the mean? Here's what I want you to think about that. If I asked you to estimate the mean from the histogram, I want you to think balance. Bring balance to the force. Imagine a fulcrum. Fulcrum's a great word, right? Right, like your seesaw, right? Your seesaw. Where would you put a fulcrum so that the weight of these bars would be balanced? Would you put it here? I don't think so, right? Wouldn't this would tilt down? Your fulcrum needs to go up, right? Maybe here. Somewhere towards the middle, but you can see the different histograms that you might get. What if you got a histogram that looked like this? Where would you put the mean? Where would you put the balance? Where would you estimate from the mean? Estimate from the histogram, I'm sorry. All right. So for those of you that were patient enough to wait through all of this, the homework handout that goes with this has a whole bunch of problems because we're not in the textbook, right? So you don't need to do every problem on that homework handout. It's just that normally when I give you, for instance, 5 probability problems to do in section blah of your book, if you want more practice, you can do the problems I didn't assign. So that's why for this case, and it was simple to do, right, to gather all this. So here are the problems that I think you should do, as opposed to doing if you don't want to do them all. One, right? One is a little tedious, but it just kind of gets you in the habit and reminds you of what we're actually doing. Do 6. And pay particular attention to 7, 8, and 10 as well. Let me look. No, especially 7 and 8. Very IB-like, these ones. All right. I will see you in our next live session.